Generate list of all possible permutations of a string. How would I go about generating a list of all possible permutations of a string between x and y? Characters in length. Containing a variable list of characters. Any language would work, but it should be portable. There are several ways to do this. Common methods use recursion, memoization, or dynamic programming. The basic idea is that you produce a list of all strings of length 1. Then in each iteration, for all strings produced in the last iteration, add that string concatenated with each character in the string individually. The variable index in the code below keeps track of the start of the last and the next iteration. Some pseudocode. List equals original string. Split. Single quote, index equals 0, 0. List equals quote, quote. For iteration n in 1 to y. Index equals index 1. Len. List. For string s in list subset. Index 0 to end. For character c in original string. List add s plus c. You'd then need to remove all strings less than x in length. They'll be the first x1 asterisk len original string entries in the list. It's better to use backtracking. Hashtag include less than stdio. H greater than. Hashtag include less than string. H greater than. Void swap. Char asterisk a. Char b. Opening curly bracket. Char temp. Temp equals a. Asterisk a equals b. B equals temp. Closing curly bracket. Void print. Char asterisk a. Int I. Int n. Opening curly bracket. Int j. If I equals n. Opening curly bracket. Print f. %s n. A. Else. For j equals I. J less than equals n. J plus plus. Opening curly bracket. Swap. A plus I. A plus j. Print. A. I plus 1. N. Swap. A plus I. A plus j. Closing curly bracket. Closing curly bracket. Closing curly bracket. Int main. Void. Opening curly bracket. Char a. 100. Gets. A. Print. A. 0. Sterling. A. 1. Return 0. Closing curly bracket. You are going to get a lot of strings. That's for sure. Where x and y is how you define them and r is the number of characters we are selecting from. If I am understanding you correctly, you should definitely generate these as needed and not get sloppy and say, generate a power set and then filter the length of strings. The following definitely isn't the best way to generate these, but it's an interesting aside. Nonetheless, Knuth, Volume 4, Fascicle 2, 7.2.1.3, tells us that S-T combination is equivalent to S plus 1 things taken T at a time with repetition, and S-T combination is notation used by Knuth that is equal to. We can figure this out by first generating each S-T combination in binary form. So, of length S plus T, and counting the number of zeros to the left of each one. 10,001,011,101 to becomes the permutation 0, 3, 4, 4, 4, 1. Non-recursive solution according to Knuth. Python example. Def next permutation. Perm. K0 equals none. For I in range. Len. Perm. -1. If perm. I. Less than perm. I plus 1. K0 equals I. If K0 equals none. Return none. L0 equals K0 plus 1. For I in range. K0 plus 1. Len. Perm. If perm. K0 less than perm. I. L0 equals I. Perm. K0. Perm. L0 equals perm. L0. Perm. K0. Perm. K0 plus 1 equals reversed. Perm. K0 plus 1. Return perm. Perm equals list. 12,345. While perm. Print perm. Perm equals next permutation. Perm. You might look at efficiently enumerating the subsets of a set, which describes an algorithm to do part of what you want. Quickly generate all subsets of n characters from length x to y. It contains an implementation in C. For each subset, you'd still have to generate all the permutations. For instance, if you wanted 3 characters from ABCDE, this algorithm would give you ABC, Abid, Abe, but you'd have to permute each one to get ACB, back, BCA, etc. Some working Java code based on SARP's answer. Public class permute, static void permute, int level, string permuted, boolean used, string original, opening curly bracket, int length equals original, length, if, level equals length, opening curly bracket, system.out, println, permuted, else, for, int I equals 0, I less than length, I plus plus, opening curly bracket, if, used, I, opening curly bracket, used, I, equals true, permute, level plus 1, permuted plus original, charit, I, used, original, used, I, equals false, closing curly bracket, closing curly bracket, closing curly bracket, closing curly bracket, public static void main, string, args, opening curly bracket, string s equals hello, boolean used, equals false, 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 permute, 0, quote, used, s, closing curly bracket, closing curly bracket. Here is a simple solution in C#. It generates only the distinct permutations of a given string. Static public I enumerable less than string greater than permute. String word, opening curly bracket, if, word, length greater than 1, opening curly bracket, char character equals word, 0, for each string sub permute in permute, word, substring, 1, opening curly bracket, 4, int index equals 0, index less than equals sub permute, length, index plus plus, opening curly bracket, string pre equals sub permute, substring, 0, index, string post equals sub permute, substring, index, if, post contains, character, continue, yield return pre plus character plus post, closing curly bracket, closing curly bracket, closing curly bracket, else, opening curly bracket, yield return word, closing curly bracket, closing curly bracket. There are a lot of good answers here. I also suggest a very simple recursive solution in C++. Hashtag include less than string greater than. Hashtag include less than iostream greater than. Template less than typename consume greater than. Void permutations. std. String s. Consume std. Size underscore t start equals 0. Opening curly bracket. If start equals s. Length. Consume s. For std. Size underscore ti equals start. I less than s. Length. I plus plus. Opening curly bracket. std. Swap s. Start s. I. Permutations. S. Consume. Start +1. Closing curly bracket. Closing curly bracket. Int main. Void. Opening curly bracket. std. String s equals abcd. Permutations. S. std. String s. Opening curly bracket. std. Q less than s less than std. endl. Closing curly bracket. Closing curly bracket. Note: strings with repeated characters will not produce unique permutations. I just whipped this up quick in Ruby. Def perms. X. Y. Possible underscore characters. All equals. Quote quote. Current underscore array equals all. Clone. 1. Up to. Y. Iteration. Next underscore array equals. Current underscore array. Each. String. Possible underscore characters. Each. C. Value equals string plus C. Next underscore array. Insert next underscore array. Length. Value. All. Insert all. Length. Value. Closing curly bracket. Closing curly bracket. Current underscore array equals next underscore array. Closing curly bracket. All. Delete underscore if. String. String. Length less than x. End. You might look into Language API for built-in permutation type functions. And you might be able to write more optimized code. But if the numbers are all that high, I'm not sure there is much of a way around having a lot of results. Anyways, the idea behind the code is start with string of length 0. Then keep track of all the strings of length z where z is the current size in the iteration. Then, go through each string and append each character onto each string. Finally, at the end, remove any that were below the x threshold and return the result. I didn't test it with potentially meaningless input, null character list, weird values of x and y, etc. This is a translation of Mike's Ruby version into Common Lisp. Defund perms. XY original string. Loop with all equals. List. With current array equals. List. For iteration from 1 to y. Do. Loop with next array equals nil. For string in current array. Do. Loop for C across original string. For value equals. Concatenate. String string. String C. Do. Push value next array. Push value all. Set f current array. Reverse next array. Finally, return. N reverse. Delete if hash. Lambda. L. Less than. Length L. X. All. And another version. Slightly shorter and using more loop facility features. Defund perms. XY original string. Loop repeat y. Collect. Loop for string in. Or. Car. Last sets. List. Append. Loop for C across original string. Collect. Concatenate. String string. String C. Into sets. Finally, return. Loop for set in sets. Append. Loop for L in set when greater than equals. Length L. X. Collect L.